this topic today. We have people joining us from across Canada. We have some of our international colleagues here today. And really, one of our goals at Channel Consulting for 2024 has been to connect people and ideas to unlock solutions. And so we are a development consulting firm based in Vancouver. And what we do is really expertise in development consulting, development approvals, government relations. And so we're really excited today to be convening a really important conversation, addressing all of the questions that we hear from our private sector clients, as well as government and nonprofit clients in regard to mass timber and its feasibility as an environmental solution. So really proud to welcome you all. Really encourage a lot of engagement in the chat. We have 3 10-minute presentations from our subject matter experts. And then I'd like to have about 20 minutes at the end for Q&A. We always try and wrap up within the hour. And just along that line, we have convened a number of different conversations on different topics over the last few years, and specifically in 2024. All of those recordings are available on our website, channelconsulting.ca/resources, and we welcome you to use those resources, to share them with your colleagues. They're here to really help up-level the industry and help make housing happen. So really proud to share those with you. And if you have any questions at any time, feel free to reach out to us. Okay, so without further ado, I'd like to go ahead and get going with our content today. So we're going to start off with Tobias. And Tobias, want to go ahead and introduce yourself?
Yeah. Hi, everyone. My name is Tobias Fast. I'm a partner here with FastNet. We're a structural engineering firm. I've done a lot of work in the mass timber space, and I'm here in our Vancouver office. We've got offices across our 3 other offices as well. And I'll just start sharing my screen here as well so we can get going. Okay, so today this will be a somewhat introductory and somewhat case study discussion on mass timber. This is the start off today. My part will be on the structural considerations, and then you'll hear from other aspects from Angela and Andrew. But my part is on structure, which forms the bones of these things. FastNet, like I said, a structural engineering firm. Core purpose is to advance structural design and propel the architectural imagination. It's really what we get most enjoyment out of and where we provide the most value. Like I said, 6 offices. I'm here in Vancouver. We've also got Seattle, Toronto, New York, and then Germany. There's Darmstadt and Stuttgart offices as well, with 125 staff total. I'll keep it quick. We'll go through 4 key things: structural systems, how these buildings come together, including their connections, some things to consider for supply, and the bulk of it will be talking about case studies, local case studies, both residential and commercial. On structural systems, so very basic, this is kind of 101. I saw there's sort of a wide smattering of different maybe experience and understanding levels on the call here. So for some, maybe this is old news, for others maybe not. But anyway, there's really kind of 2, the differentiation between mass timber framing from lightwood framing. Lightwood framing is what we're used to, excuse me, in this province as far as under 6 stories. Dimensional lumber, build in place, some perhaps levels of prefabrication. Mass timber is large panels from dimensional lumber. So you're looking at this very similar materials in the top and bottom photos, but one is prefabricated, one is larger dimension elements, and with longer spans, higher capacities, bigger buildings. You break down mass timber as a broad word. You can kind of break it down to a couple different panel types or different material types. There's nail laminated, dowel laminated, glue laminated, all sorts of ways of laminating these things. Plywood, stick plywood together and glue it together, cross laminated timber. These all sort of make up what we call mass timber, and they're all fundamentally structural elements that that compose of a building's primary load-bearing structure. So I won't go into depth on these, but this is generally when we're talking about mass timber, and these are different subcomponents of that space. As far as gravity systems go, there's a range, but in general, the bulk of buildings that you'll see are formed in one of these four ways: post and beam. It's kind of the traditional mass timber format, what you'd probably see down in old Gastown buildings, right? It's post and beam, very simple construction type. Full panel is a newer one now with the advent of, or with the advent, I guess, happened maybe several decades ago, but larger, broader sort of market share of full panel suppliers and producers now enables panels for floors and wall elements. Stick and panel is a nice hybrid, and you're seeing that around town with stick frame walls and mass timber panels for the floors. And then post and panel is, I'll share a couple right away, is sort of what you might compare with the traditional sort of cast in place flat plate concrete systems. That's being used in a lot of multi-unit residential mass timber construction right now. Grids are very important in this space. Typical residential grids for a point support system, that's the last system I showed on the far right of the last slide. These are smaller grids. These are like 11.5 by 15. This is all dependent on the supplier and what they can produce. This is no beams on the right-hand side. You see more traditional post and beam grid, and it can get larger to 20 to 25 foot spacing. This is more in line with what you'd see in concrete construction, steel construction. On the commercial side, then you're going larger, you're going all primarily beam type systems, 20 by 25, 30 by 30, even larger if you really want. But really, the left two are kind of what you would see most commonly. And so these are traditional grids, is what you'd see in, again, the concrete and steel space. As far as lateral systems go, you can do the whole range. Most of what you'll see is on the right-hand side, so traditional concrete cores, especially in the lower mainland area here. That's what everyone's used to. And you go to other areas, other cities, and you might see more steel, you might see more wood. It really is largely dependent on local market preferences and cost of materials locally. But you can do timber frame systems. I'll show you one in a second. But primarily you'll see concrete core and steel frame systems. Timber brace frames, you can see here, pretty self-explanatory. CLT shear walls for smaller sort of squat buildings. This is kind of a nice way where it's all, the entire structure is just wood. We're doing this as the elementary school in the lower mainland. Steel brace frames, we all know about this. And then concrete cores, like I said, especially in Vancouver, makes up the bulk of lateral systems, even for timber structures. Okay, structural connections, how they actually get connected together. There's myriad ways these buildings can come together, and columns and beams can get connected. I'm showing one type here. These are form-fit hangers. You use these kinds of systems. These are pre-engineered systems, and really allow for really no visual impact. You don't see, all you see is wood to wood. So that's a benefit. There's other systems, bearing systems. Here's some beam to beam connections. You can see it's really just landing beams on top of other beams, some notches, some form fit hangers, some custom plates. One of the main takeaways here is just that there's many different ways these can come together, which is a pro and a con. On the positive side, you really have, if you have architectural preferences, if you have fire rating preferences or requirements, if you have fabrication considerations, one fabricator prefers one, you can go many different directions. Downside is there's not a lot of standardization right now. And so look at, all of these are possible. You have different screw kinds, screw types. And so it's just a bit of an open market in this space right now, but many different ways these can come together. Here's an example of a form fit hanger with a Rikon. These are a lot of these came out of Europe, Central Europe, Germany, Switzerland, Austria, and have now made their way over here, as well as some new connectors on the market by local suppliers. Column base is just fairly simple. Just get the load to the ground. Generally, some manner of steel or aluminum is involved in the connections here. Okay, into supply considerations. So these all come from logs, and we have a big, massive forestry industry here in British Columbia, obviously. However, doesn't give you the full picture. A lot of the the timber projects here are supplied locally, but certainly not exclusively. This is a big long list, and it's probably out of date. I've been using this for a while, so you should probably go and have another pass through it. However, you can see in Canada, for example, we've got 2 within British Columbia, 2 active in British Columbia. Discussion of more, but currently there's 2 suppliers that you can get local, in general, local material from. That's Klesenkov and Mercer. And then throughout Canada, we have Nordic, Element 5 out on the East Coast, Western Archer supplying Glulam from Alberta. United States, you've got some more options, including several just south of the border. And then in Europe, there's a whole other range that's been going on in Europe for much longer than it has in North America. And so the supply market's a bit more mature there and a bit more developed. And it's not out of the picture for these suppliers to bid competitively on projects in North America, especially when you think of projects on the East Coast, more so than on the West Coast. One of the things to just consider here is, or there are many things to consider when engaging suppliers and considering where your fiber is going to come from, what kind of fiber you're going to be specifying on your project, and what kind of finished product you want in the end. It is hard to design for everybody. These are very specific machines and setups that produce these panels. And many of them have varying geometries. So you get varying panel types, and you also get different wood species. You get different layups, so different lamella thicknesses, grades. These are unique machines, like I said. Shipping comes into it. These panels, often you're limited by the keeping elements within the size of standard shipping lengths and widths and heights. And so that can, even though the panel supplier can supply something bigger than the truck, that's much larger, the truck is often the limiting factor. Anyway, there's a whole world in there. Like I said, we've got only a handful of minutes here, so I won't get too deep into those, but I want to kind of look at the few case studies which might be of most importance here. So the first one is an old, well, I guess we say old as far as mass timber in the Vancouver area, but this was done, it's getting close to 10 years, not quite 10 years, but in the last decade, this project was topped out. This is tall wood at Vancouver, in Vancouver at UBC campus. Probably heard about it. It was the tallest at its time of mass timber, tallest mass timber structure in the world before being eclipsed by a Norwegian project. And this was all using point supported CLT. So this is a student residence building. And you'll see this often for any sort of developers on the call considering multi-unit construction, taller than 6 stories. This is often, or this is a good option. You see a lot of columns. So it's really, the columns are set at the edges of the panels. And so it's your panel width that determines often the grid of columns that you'll have. And this is a beamless system. And so this gets as close as possible to that sort of 3 meter Vancouver classic, or 2.9 meter to 3.0 meter floor to floor height. And that's with roughly 6 to 7 inches of CLT for your floor structure with topping on top. This building was very successful. It came in quite competitive against cast in place concrete, which was a benchmark for it, and was really sort of set off quite a large movement in this space. Prefabricated wall panel systems all went together quite nicely and quite quickly. I'll keep going, so I think I'm running behind here, but this is BCIT. This is sort of second generation. This is the student residence building, which just has topped out recently on the structural side. This is 11 stories. This is out at Burnaby, their campus there. This is the same system except with steel columns. This is to allow narrower dimension columns. They fit within the partition walls. You can see all the columns stood there, single story columns, 4 bolts and the connection to the next column. Waterproofing on this project was sort of the Cadillac version, the highest level of temporary moisture management, which is a big deal, as many of you know. A fair amount of money spent on this one, and it worked well. Shop applied membrane, then sealed the splines, checked the moisture content before sealing things up, all that good stuff. Steel braced core on this one. The whole core was prefabricated ahead of time. So in 2 lifts, I think 2 or 3 lifts, 4 stories roughly per lift, and then installed in time so the crane could be done. and could focus on flying timber panels and steel columns like you see here. Flint speed wall system for the exterior curtain wall went really well. So that's the sort of small unit residential space for student housing, social housing, smaller condos. That's where you'll see that. And there's about a few more of those in the mix right now in various stages of design with private and public clients. Lastly, I'll talk about the hive. This building is it's structurally topped out now. This is in East Van here. And this is an all timber. Timber is some hybrid elements, but primarily a timber structure. This is where ICBC is going to be moving into. This has been developed by the Nature's Path group. This is Kalashnikov timber installed on site by the iron workers. Clear spans all the way across the quarters, a 3-bar building. There's flush steel beams. These are custom steel beams, custom fabricated to support the panels at the edges, or the inside, I should say. Steel or timber braced frame system, the tallest timber lateral system in a high seismic region right now. Quite innovative. These innovative dampers, which we also have in our building here, Fastnet's home office building, to allow high levels of energy dissipation for a damage-free structure post design earthquake event. CLT shear walls as well. Lots of testing and research done on these with a unique rocking base system. And you can see those prefabricated panels getting flown into place. This building is now much higher than what you see in these photos, but it looks quite stellar. And this is kind of the other end of the spectrum as far as mass timber structures go. I showed you kind of the most cost-effective way of going for taller timber buildings on the residential side. On the commercial side, you can get buildings like this, you can get spans like this to create credit premium interior space using timber. That's it for me. I am going to hand it over to Angela.
Great, thanks. I'm just going to share my screen. Can you guys see that? It seems like I only see myself and on my screen, so I guess it's just on that side there. Yeah, good to meet all of you guys. So my name is Angela Lai. I'm the managing partner with Core2. We're a QS firm based locally in Vancouver, otherwise called Cost Consulting, if people don't know what quantity surveying is, but we do estimating, we do load monitoring, we do development management, project management, and we've been working in the mass timber space for a few years now. It's something I kind of enjoy getting involved in, trying to make the case for mass timber. So moving on to my discussion here. Yeah, so basically the mass timber construction has a lot of technical advantages. So one of it is speed of construction, which I'll touch on a bit later. There's also the quality of construction because it's manufactured in a factory. So there's basically better tolerances than if you were manufacturing it on site. And obviously there's the sustainability aspect of it because Canada, we have an abundance of the material. The mass timber industry, it's far more advanced in European countries like Germany and Austria. But over the past few years, we're starting to find that it's had a lot more traction. But you could see with Tobias's presentation, it's not new. It's been around in Canada and BC for quite a long time. So that is one of the things that would have a cost consideration impact, is the fact that it's has a perception that it's still quite new. Okay, so moving on to capital cost, which is kind of the key thing, and I will go through some case studies. So why I mentioned capital cost, because I will touch on life cycle cost in a bit, but mass timber versus wood frame. So wood frame tends to be about 13 to 14% cheaper than mass timber, but keeping in mind that with wood frame, you can only build to 6 stories. Anything above that, obviously you go into concrete or you're going to mass timber. Obviously, you are getting some of the advantages with stick frame now as well, because you can go to a panelized system as well. Okay, now looking at mass timber versus cast in place. Obviously, with cast in place concrete, you're going to get the density that you want. So anything that you want more density and higher, cast in place concrete is preferred. Now, you probably wonder what the cost premium is. So we've done some recent costing. The premium is around 6 to 9%, but in being in numerous workshops and speaking to numerous contractors, we can get it to as low as 5%. With mass timber and steel, steel is one of those materials that will always have a cost premium, particularly regionally in BC. There's about a 6 to 8% cost premium on that in terms of mass timber over steel. However, I must say that I haven't come across too many steel buildings. I mean, the kind of favorite choices tends to be wood frame and concrete. So in terms of timelines, now, so the question I always get asked is, is one going to be much faster than the other? So mass timber, because it is kind of modular, it is a modular system in essence, just like we have the other systems. So it can be 5 to 10% faster than wood frame. But then obviously, like I mentioned before, stick frame, they are moving to like a panelized system, which can be a lot quicker, which is the study that I'm working on, which is the CMHC level up project, where we're looking at doing things faster and in a more efficient way. Now, the one comparison I always get asked is how about concrete and mass timber? So it can be 30% faster, particularly on site. Once you bring the systems onto site, it's just kind of like Lego putting the pieces into place. One of the projects that Tobias had up there was the Bok Commons project, which is an 18-story student residence. And I think they were doing basically building it. They built it really quickly. But in essence, you have to consider the upfront design and prefabrication, which kind of can offset the actual time that is actually on site, because the fabrication could take months, but then obviously you have the quicker part of it on site. But even though it might be quicker, there's obviously the logistical issues and making sure you have the team in place, making sure that there's place for storage of the materials, and so on. In terms of compared with steel, both are kind of modular systems, so I don't really see that there is any timeline or schedule saving between the two. Okay, now I have the life cycle piece on there. And life cycle is kind of my area of particular interest and expertise. Now, the thing is, it's structure. So unless you're going to demolish the building, it's not something you're really going to be considering. I mean, and in terms of the life cycle piece, which is mostly the interior finishes and the mechanical systems, that is probably going to be very much similar for all three structures. Obviously, where you're getting the advantage is when the building is actually demolished, what pieces can be actually salvaged and reused, which is obviously less in the case of concrete. But for me, and I didn't kind of put this up here, it's more about the life cycle assessment, which is the embodied carbon of mass timber. Now, there isn't really good benchmarks on mass timber versus concrete, because obviously we're still doing a lot of life cycle assessment, but definitely there is a lower global warming potential with mass timber than there is with concrete. Okay, so kind of I match with Tobias' slide there in terms of all the suppliers in Canada. Now, the thing is, even though I said we're moving towards mass timber, using more of it, there is a limited amount of supply, because of all those people that I have listed there is only one that is actually based in BC, which is Kalishnikov. They're based in Castlegar, BC, and I'm using them for one of the projects. Structurelam was bought by Mercer. We have Nordic in Montreal, BC, and Elements 5 in Toronto, and Western Arc in Edmonton, Alberta. So my point is, yeah, we can use mass timber, but there's a limited amount of supplies, which is one of the things that is adding to the cost premium of mass timber. So there's the Height Building, which is basically a project that we were working on as a third-party payment certifier. But just the kind of key things in terms of procurements of mass timber suppliers is just pre-qualifying contractors and making sure that they have worked with mass timber before, because if they're new to it, it's going to draw a cost premium. The other thing is obviously your on-site logistics and making sure that's all in place.
Thank you. Trying to share my screen here. Are you seeing the screen?
I actually have to stop sharing. Sorry about that.
Can you see my screen?
Yep, we can see it.
Good, thank you. Good afternoon. Thanks, Angela. Just very quickly, oops. No, I'm not. GHL is a fire engineering firm involved in mass timber. Most of the projects that Tobias mentioned there, and some that Angela mentioned there as well. We base our design on fire engineering. We had a significant amount of research. First, a quick territorial acknowledgement. We respect our work takes place on traditional unceded lands across the province. Oops, something's a bit finicky here. I have my background is civil engineering and also fire engineering. I have a master's degree in fire science from UBC, which they had for a very short period. I started my work with a lot of old heavy timber buildings, and that's what created my passion for it. We did some studies on 6-story wood frame was our work, and multiple research background. And I said this because research is very important, I think, to understanding how wood frame building, mass timber buildings work. Heavy involving committee involvement. And some of the building worked on, UBC Brock Commons, Tobias mentioned, Earth Science is very early building. We are working on Limberlost Place in Toronto, which is a 10-story fully exposed mass timber building, as well as the High, which again Tobias mentioned. There's actually relatively few buildings that have proceeded of this size. So it's a very small market and limited number of people with experience in it. Little bit of background on fire testing. This is a very one we did in Richmond to demonstrate to authorities, to code officials, municipalities, firefighters. We actually burned a sample of light wood frame construction, both completed, that is with the fire rating installed, and uncompleted during construction, and then a similar mass timber building. This is shows very clearly what the difference is. You see here that the light wood frame building burned up in a room burned up in almost no time whatsoever. Whereas the other two survived quite well. The mass timber building, in the end, the mass timber building, although everything is exposed, you note the garbage can fire burned out and just charred the background, the back panel there. This is another large test. This was actually done in Ottawa in June of 2022, part of a large provincial national study. I think 6 provinces and the federal government contributed to it. This was the largest office structure. It was effectively mimicked a fully furnished office, albeit we can't burn plastic, so everything was done in timber. Burned for about an hour. As you see towards the end there, it actually burned out, and in the end it remains fully standing. The comment they put in the report was the elements were largely self-extinguished within the first hour. The test was continued for 4 hours to monitor any potential reignition, any structural failures, and the building survived. They actually did 3 more fire tests in that building. Some major change happened in BC recently. In the spring, we've now increased the size of buildings effectively up to the same as the US codes allow. We had an anomaly that BC built the 18-story Brock Commons building in 2016, I believe. And yet our national code only allowed 12, whereas the US came up and studied what we did at UBC and added 18. So now we have 18 stories. We have answers or options for all occupancies. It was led by BC and it's submitted to the national code process and going through the national code process with different types of encapsulation. And here on the left is a table, different types of occupancies, maximum number of stories allowed. For example, assembly buildings are slightly shorter. And I'll talk about encapsulation rating in a second, but fundamentally different options, either fully protected, partially protected, or fully exposed. Exposed ceilings are permitted up to 8 stories. The city of Vancouver does not yet permit exposed buildings in residential buildings. Their concern is that they may be modified or changed by occupants. I'm not sure how realistic that is, but that's the concern, and that they cannot inspect residential units. However, we have negotiated alternative solutions. up to 24 stories with exposed ceilings in the city of Vancouver. The problem with exposed ceilings is it does require significant additional timber. One big change, a lot of concerns with the requirement to encapsulate the building that is protected with gypsum wallboard as you construct. They now have changed the code to provide options, and we've done that as an alternative solution in many buildings in Vancouver. Just talking about encapsulation, the fundamental concept of mass timber buildings initially was that all the timber would be protected with drywall. They put 2 layers of drywall on it to protect it for approximately an hour, all the complexities I won't get into. And the fundamental idea is part of your protection is from the gypsum wallboard, and part of your protection is from the timber, not all of it. This gives options and economic options that need discussions, and the carbon balance may be part of the discussion here. You can actually have full encapsulation, and we assume that there's no char allowed, but that would be 3 layers of 5/8 type X or 4 layers of 1/2 type X gypsum wallboard, and then you get no char in the timber. It might enable you to do a 3-ply CLT. That is a 5-inch CLT panel for a 2-hour building. That's the approach we use at Brock Commons at UBC, 3 layers, 5/8 type X gypsum wallboard. Lowest timber cost, high gypsum wallboard cost, and the carbon impact is of course greater. Most of the buildings that currently are 2 layers are a hybrid. They have some protection by gypsum wallboard, some protection by char, 2 layers of 1/2 inch. So you lose 1 to 2 plies of your CLT to char. Not so significant with other types of timber, but you always end up losing some timber to char. And fully exposed buildings, they say they're now permitted up to 8 stories for residential and office, but you lose a significant amount of char, 90 millimeters of timber. And this goes back to the table. What they came up with was for a residential building, we look at the 3rd line there, apartment hotel, 18 stories, 70 minutes of encapsulation. So that requires 2 layers of 5/8 type X, up to 12 stories, 2 layers of 1/2 inch type X, and up to 8 stories, no protection, to give you an option and a scaled approach. Connections are a big issue. Connections in these buildings need to be protected, and we really have very little guidance on connections and very little testing. Protection by basically 4 inches of timber or gypsum wall, 2 layers of gypsum wallboard is required for steel protection, the only really tested protection method. Protections require a lot of very careful design and interface between the structural and the fire engineers on the project. We did a series of tests of connections, unfortunately not loaded. Testing is a very expensive process and always looking for money. But we looked at exposed unprotected steel column, gypsum wallboard protected column, intumescent paint, steel plate hidden inside the timber but with the edges exposed, and the 3 inches of timber protection. And here's an example of a test furnace with a steel column in the test furnace supporting a CLT floor. Go through there. And there at the end, you can see the amount of char you get on these. Effectively, there was a 3-ply CLT. We had 2 plies left at the end. Here are a lot of comments about fire stopping. There are lots of fire stop solutions out there, although many people are not aware of where to find them. We have been involved in excess of 40 different penetration fire stop tests. Some companies have some solutions, but they certainly don't cover all solutions. You almost always need someone with familiarity with timber to help you work through the fire stop designs. Plastic pipes are very difficult fire stopping because the pipe and the fire stop is proprietary, and the relationship between the two is very important. We do have a problem with many of the fire stop engineering judgments that we see. They ignore the fact that timber burns, for example, and as a hot steel pipe touching the timber will cause the fire stop to fail. So you need a fire engineer who understands what's involved. There's a sample fire stop testing. Another example here. This is from Brock Commons. We had 2 layers drywall protection, successfully fire stopped the timber. General thoughts, we always end up with alternate solutions on these projects. Vancouver, North Vancouver, Richmond, Kelowna, very cooperative. Toronto's been very cooperative. Winnipeg, some authorities are very reluctant to accept alternative solutions on these issues, and you really need to know and understand what the authority's perspective is. Speed of construction. I really don't feel the speed of erection is currently factored into costing. 3+ floors per week on a simple building is certainly done with multiple small teams. Speed of construction is always hampered by other team members' expectations. You find a lot of the subcontractors schedule their projects based on what they expect from a concrete building or what they expect from other timber buildings that haven't gone well. And you need to make sure they integrate, understand the speed of construction. And we will see a lot of refinements as they get to know it. We should also see, they should see it facilitate more integrated electrical systems, plumbing systems, wall and floor modules. So Lego-like systems will be the solution. Material is more expensive than concrete. There's no getting around that. Most contractors find mass timber to be expensive. We consistently see an upcharge, although we consistently see that the subcontractors, and people may look at the structural materials in detail, but the impact on subcontractors is rarely assessed, and it's typically just an upcharge on what a concrete building would cost. However, in the 6-story area, we see 2 developers who are finding efficiencies. They've both done multiple projects, which show a reduction of costs with experience. They both have close relationship with their subs to realize the value of the cost savings. That is particularly plumbing, electrical, insulating trades, so they understand how to work. And they've gains in cost savings and speed and efficiency through dimensional stability and significant savings on construction duration, which also translates to savings on construction insurance costs as well. So I anticipate that when we have a developer who's done 3-5 large mass timber high-rise buildings, we'll start to see the cost decline significantly more, but we're not seeing that yet. Design cost is innovation, as Angela said. All consultants need to develop new details. All consultants have a wide range of details for a conventional concrete building, conventional wood frame building. You have to reinvent those details for mass timber building. And find a good fire engineer so you're not hindered by code restrictions and lack of familiarity. And with that, I'll pass it on to questions. Thank you.
Okay, awesome. So Andrew, if you could take off your screen share, and Des, if you could pin the 4 of us, that would be awesome. Okay, well, I just want to say a massive thank you to all 3 of you presenters for a really comprehensive overview on the issues with mass timber solutions. Please add your questions in the chat. Just going to see if we've got anything in there. I have some questions to get us going, but please go ahead and add your questions in the chat. My first question came up from Tobias when he was talking about Tall House at UBC, and he said that it was eclipsed by the Norwegian project. And so I wanted to know a little bit about the tallest buildings that you've seen globally, particularly for residential.
Yeah. The one in Norway, I always forget how to pronounce it, so I won't try. But it was 18 stories as well, but just a higher floor to floor, and a really striking design, big exo like timber frame skeleton, which I think was hotel and some office space, if I recall correctly. And then that was biggest for a while, and then Ascent in Milwaukee, which is a private development, market development. By Newland Enterprises, right on the lakefront there, and that was a post and beam with concrete core. Was the tallest and still remains the tallest. And there's a bunch in planning, or not a bunch in planning, I should say. There's many design proposals out there and things like that. but there's a couple tall ones now in Portland and in Seattle. And then here in Vancouver, for the Vancouver Affordable Housing Authority, we're designing, and Kindred and CGF, and I think Andrew involved in that one as well on Bird Street there. Is 18 stories, very similar to like the Brock Commons style building. And then also with a couple, or there's a couple of private developers building 18 and then 124 proposal here in Vancouver on Main Street as well. So lots in the mix, but currently the Milwaukee's still the tallest.
Okay, great. And actually, Andrew, you had mentioned the 24-story and some of the work that you did on proposing alternative solutions with the building code. So what is the status of that project? Has that been approved by the city?
Approved by the city in concept.
Okay.
They haven't yet gone for building permit.
Okay. Okay, great. Awesome. Awesome. Okay, and Angela, we had a question for you. You just briefly touched on, when you talked about cost estimates, you briefly talked about carbon impacts. Can you talk a little bit and just elaborate on the benefits of mass timber from a carbon perspective?
Okay, so obviously with mass timber, you're using a renewable resource, but it also, there's sequestration of of carbon, which you get with mass timber as opposed to using concrete. So we also do life cycle assessments, which is obviously different from the costing piece. Actually did one on one of the studies that I put up. And the way you kind of do it is you measure in terms of global warming potential. So one of the things that we're finding, and it's actually mandated by the City of Vancouver right now, that when you issue a BP application, you have to submit a life cycle assessment with it. So the particular one I came up with, it was 348 kilograms per CO2 per meter squared. Now the thing is, like, what do we judge that by? There's not a lot of data and research on actually benchmarking. There was a recent study done by Athena, which basically says global warming potential of concrete is 3 times as much. But then keeping in mind, it's probably not going to be 3 times the 348 because a lot of mass timber are hybrids. So the one I did, the study one, was the 16-story. It was a post and panel system. So it essentially had 2 levels of underground parking. So there's a fair amount of concrete in there as well. And then, so it's not, until we do something that is completely mass timber, it has the mass timber core in that, it's kind of hard to judge. But what we use is the Athena Institute software. There's tons of other software there. The other thing just to consider about doing life cycle assessments is the system boundary. So we're not actually doing life cycle assessment on the entire building because there's some things that are not considered. Like particularly mechanical and electrical systems. So our focus is on the structure and kind of the structural system and the partitions, which is the drywall and the gypsum and so on. So the system boundary is not the entire building, but of course it is to say definitely the global warming potential of mass timber is definitely lower than steel or concrete.
Okay, awesome. Okay, we have a question from one of our international colleagues here. Marina is joining us from LAI Madrid. And her question is in regard to how many of the timber frame buildings in Vancouver have an environmental certification type of LEED. Andrew, would you be the right person to talk about LEED?
I can't really comment on that. Wood frame construction is extremely common. Hundreds of 6-story light wood frame construction. Mass timber is relatively new here. But I don't think many of the light frame buildings have gone for LEED certification.
Okay, and can you talk maybe a little bit about the sort of green building threshold that we have here in BC and why they wouldn't be going for LEED certification per se?
I can't really comment on that, I'm afraid.
Okay.
LEED is not my area of expertise.
Okay.
Okay.
Okay. Well, Tobias or Angela, would you have anything to share on that one in terms of lead?
On the lead.
Yeah.
Yeah, so what I'm finding on a lot of projects, there's been a move away from lead. There's been more focus on the BC step code in terms of BC. I have one project that's looking at the Living Building Challenge because lead is one of those environmental assessment methods that don't have quite as much tangible benefits. Like, for example, passive house, you're getting the comfort levels, you're getting the energy savings, because you can get the lead points from a whole bunch of different things which are not necessarily associated with the building. So to be honest, I've seen not many, and if they do follow it, they tend to have just kind of follow the guidelines rather than actually seeking accreditation.
Okay, thank you. Okay,
There's a-
Brittany has a question. Oh, Andrew, did you
I
have
was just gonna
another?
note, there's a comment in the chat there about the Deer's Well building as having, Deer's Pura building having the well certification.
Okay, and yeah, Rocky, thank you for that. If there's anything you could share with Marina, like a link to the project or anything in the chat, I know that would be gratefully received in terms of exchanging ideas across the globe here. Okay, so Brittany has a question. Fantastic presentations. Yeah, I agree. Does the size of the building affect the cost effectiveness of mass timber instead of typical construction materials?
I think it's going to be with anything that you get economies of scale the more you buy. So if you're going to be building a little building as opposed to something that's much larger, you're going to obviously pay a cost premium on that. But I think it's going to be the same with any other material. So I haven't actually done a study to see what it is, but there's definitely, it's going to be the same as with other materials.
Okay, okay, great. Sean is saying most building certifications such as LEED are focused on operational carbon emissions, typically driven through performance of building envelope and M&E systems. Okay, any
That would be
opinions?
house, I would say.
Pardon me?
I would say that would be more passive house. They build an envelope
Okay.
and the mechanical electrical systems. Because LEED, obviously, you can get in terms of sustainable design, being close to transits and, not affecting the wildlife at night and things like that. So I'd say it's definitely passive house and BC step code.
Okay. We have a comment here. Any opinions on using CLT panels for bridge decks or MT for bridge applications in general?
We've included it in certain respects. There's a Kingsway Bridge has glulam arches, and so certainly can be done. As far as the actual bridge deck, you'll see that for not necessarily CLT, but you'll see like large dimensional timber in logging road bridges and things like that. It's very common, but more for temporary cases. In general, just the thing to watch out for is species and moisture. So keeping it covered. There's also one in Princeton, a covered wood arch bridge. All over the East Coast, you'll see wood covered arch bridges, and so it can be done. They want to look up a more recent famous one in New York City. The Moynihan Connector is an Alaskan yellow cedar timber truss bridge, all fully exposed. So certainly can be done. CLT is generally SPF, so not as good at the outdoor elements. You're wanting to use grades of timber or a species of timber that are resilient, or cover it up, make sure it doesn't get exposed to direct sun and rain.
Okay, maybe this is a natural follow-up. This is from Chantel about the type of mass timber systems for achieving typical spans commonly seen in concrete warehouse designs and how it compares in terms of structural performance and cost effectiveness.
Yeah, I can speak on the span part of that question. We've done several of those studies, and there are several suppliers, timber suppliers that we've done these buildings for. So long span, it's kind of like similar to the tilt up construction that you'll see in a lot of, the Fraser Valley, tilt up concrete construction. So you can do CLT walls, tilt them up, and then generally for the roof panels, doing sort of like T-beam type timber structures. So we've got one active in the Kootenays right now that's doing that system, and a second one that's been built out there. as well as feasibility studies for big warehouse, big like multinational companies wanting to go greener with their warehouse buildings. So it's certainly an option. Again, as far as the cost goes, maybe Andrew, that's one for you. As far as what I can chime in there is in many of those cases, the people building those facilities have been with suppliers, and so it's just a difference. They can get the material quite cheaply, cost effectively. And then in the other cases, the motivation there from a sustainability, these groups have massive, hundreds, if not thousands of these facilities. And so wanting to do things differently from a carbon perspective has been their main motivation.
Okay. I'm just aware of the time. We have 2 more minutes. Angela, did you want to make a comment on that in terms of cost effectiveness?
Well, essentially, the system that you'd be using is person beam, because you're getting the, I mean, it really just depends on the design. So, yeah, I actually haven't done a cost comparison between person beam and person panel, but obviously person beam, that's what you would typically use to get the spans. Is that correct, Tobias?
Yeah.
Okay, so we have a last question here, and maybe it looks like an Andrew question, actually. Any software used to analyze how the fire would spread across the building? Any comparison to actual test results?
Fire modeling is an expensive endeavor, so there's not been a lot, and a lot of the basic information is not there. Software so isn't really helping us. We do have now a significant library of significant large scale tests to work with to give us a visualization of what's happening. I think the same goes for all materials. It's not just timber. It's still mostly based on actual test results. But I did show that slide, and I'll make my slides available, of the large tests. I would look at, if I can remember it, there's a website worth looking at, firetest.cbc.ca in the chat.
Awesome.
There's
Great.
looking at
Awesome.
for fire testing.
Perfect. Okay, I'm aware of the time. We're at 1 o'clock, and I just want to be respectful of people's afternoon commitments. Thank you, Andrew, Angela, and Tobias, so much for so generously sharing your knowledge with all of us today. We have recorded the session, and it will be available to those who missed it, and you'll also be available to share it with your colleagues if you'd like. We really thrive on feedback, so Des has included the link in the chat. Please share with us your feedback about today's roundtable, about other topics that you'd like to learn about in 2025. We value this community and the diversity of exchange of people and ideas tremendously. So thank you all so much for joining us, and we look forward to seeing you at the next one.